Hi, welcome. We want to look at why writing a quadratic expression in this form is important. This form is called the vertex form. Okay, so I'll be giving you some reasons why this is important. I have made a video that explains how to convert a quadratic expression or equation into that form, and the link is right up there, which you will do good to just familiarize with how this is done. Okay, so the very first reason is it easily identifies the vertex. So maybe this is a quadratic curve right there, right? If you have the equation of this curve and you have written it in this form, then you can easily identify the vertex right there, that point that is called the minimum. Okay, or if it's a graph that has a maximum, that is a graph that is this way instead, the maximum right there, just writing your equation in this form helps you to pick it out. And how does that help you? Make sure you choose the negative of whatever this is. So since this is minus h, I'm going to choose h and choose k. H, k here will be your maximum or minimum. Okay, it's as simple as that. All right, so we are going to take an example to explain that, okay? So here's an example. Say you have been given your f of x to be x squared, okay, plus 7x plus 12. Our first point of call is to write this in this form. We need to write that in this form. Again, I've told you that there is a video that explains that quite well. So I'm going to be a bit fast on this one. Okay, so what I want to do is to pick this, okay, and write it as a square. And to do that, I just need to write this as x squared plus 7x, then plus 7 over 2 all squared. And if you notice, I've brought this in, okay, so I'm going to have to take it out because it wasn't there before. So I take it out and then I add 12. So essentially what I've written here is the same as this. Okay, now having done that, I just need to now simplify it. This trinomial here is the same as x plus 7 over 2 all squared. And then I need to only simplify this. And if you do that with your calculator, you should get negative 1 over 4. Okay, so what I've done is I've written my y or my f of x in vertex form. Now to choose the vertex, all you need to do is to choose the negative of this, negative 7 over 2, and choose this, negative 1 over 4. And this is the vertex, okay? What I will do is to show you a graph plotted, okay, for that function, and then you can see for yourself. Okay, so what I've done is to use a graph plotter to plot the graph, and then I've copied that and I've put that here. You will see that the minimum part here is just in the middle of minus 3 and minus 4, so that's minus 3.5. And if you trace this down to the y-axis, you will see that it's just at negative 0.25, okay? So yeah, easily you can pick out the maximum minimum. Let's go to the second reason. The second reason is that it shows us quickly the axis of symmetry. Of course, the axis of symmetry is that axis through which you can divide your graph into two equal parts. Now you know that the axis of symmetry always will pass through the middle, right there. Okay, which means that by extension it passes through the minimum or maximum of your graph. Okay, so just by writing your equation in that form, you can easily pick out the axis of symmetry. And in this case, the axis will be x equals to negative 3.5. Okay, that takes us to the third reason. The third reason is that it clearly shows how the graph is transformed from the parent function y equals to x squared. Okay, so this is quite interesting, yeah? The parent function of quadratic graphs is y equals to x squared. Easily, if you are going to sketch this, this is what it looks like. Okay, so my line is going to be wobbly. Forgive me. Okay, so y equals to x squared, we usually look like this. All right, now I would like to bring the equation of this graph to 4 here. That equation, after writing it, is y equals to x plus 7 over 2 all squared minus 1 over 4. Okay, so this plus 7 over 2 here is a horizontal movement towards your left. I know this is addition, but the way it works is it moves you towards the left just by the same amount of 3.5. So we are going to move this towards the left. Let's use another. So here is negative 3.5 because it moved towards the left, and you can see that it draws that right there. Okay, and then this negative 1 over 4 just brings it down. The negative 1 over 4 just brings it down. So what we're going to do is bring it down a little bit, 1 over 4, and you can see that if I use a different color, it just brings it down a little bit, just like so. Okay, so I'm going to clear this and then this other one. So you see what I'm saying right there, it's still at 3.5. Okay, negative 3.5, but it's come down negative 0.25. Okay, that's why the y value is negative 0.25. So with this form of your quadratic equation, you can easily sketch your graph because it just shows you what transformation has been added to the parent function to give you what you have. And that takes us to the next reason. Okay, so here's the 4th reason. I know I said I was just going to do 3. Okay, on to the 4th reason why the vertex form of a quadratic expression is important. So this is the graph of f of x equals to x plus 7 over 2, which we've been treating, minus 1 over 4. So that's this graph. Now, writing it in this form is important because we can restrict the domain so that the inverse will exist. Okay? Right now, the way it is now, the inverse will not exist. And I'm going to tell you why. The way it is now, if I invert it, this is what I'll get. So this graph right here is supposed to be the inverse function. But unfortunately, it does not pass the vertical line test. I hope you do remember what the vertical line test is. So you can see that there is a single input, in this case of x equals to 10, right there. But if you put it in, what happens? There are 2 values for y, one there and another one here. As you know, that simply ensures that this particular, I don't know what to call it, is not a function. So the only way to make this graph a function is to restrict the domain, essentially cut out half of this up to the minimum. And since by this mode of form, vertical form, you know already that the minimum here is at negative 3.5. So you can restrict the domain and just make x be greater or equal to negative 3.5. And what happens if you do that? This is what happens. Okay, half of the graph is cut off. This part here is off, and then you have this. And if you invert this, this is what you get. Okay, so this is where we stop. Goodbye, see you next time.